All right, so this is the assignment that Pfaff put up. It's not due, but he asks you to do them and make sure you understand how to do them. So this is Hookes Law. The formula is F equals Kx. Remember that if you need the force of weight, you're going to do mass times gravity, and there's gravity. So F stands for force. K is spring constant. And that's going to be newtons per meter. And X is the distance that the spring stretched or compressed. So that's going to be meters. And force is newtons. All right, so this one says a spring has a spring constant of 0.7 newton per meters and is stretched 1.5 meters. What is the force? So you're just going to say force equals Kx. Force equals 0.7 times 1.5. And that is 1.05. And that's newtons because it's force. Now it's stretched 5 meters, so 0.7 times 5 is 3.5, and that's F equals Kx. K is the same because it's the same spring, so the spring constant doesn't change, and we're looking for the force when it's 5 meters. Next one, how far will 20 newtons of force stretch a spring with a spring constant of 140? So this time you're looking for the x. F equals Kx. The F is 20, K 140, and X. And then divide 140 by both sides. 20 divided by 140 is 0.14 meters, so that would be about 14 centimeters. How far will a 50 Newton force, same spring, so we're going to use the same spring constant, F equals Kx. 50 newtons equals 140 x. Divide 140 by both sides. 50 divided by 140 is 0.36. So that's about 36 centimeters. Number 5, a spring is stretched 0.15 meters, force of 1,500 newtons. What is the spring constant? F equals Kx. The newtons goes where the force is. The K we don't know. The X is 0.15. So divide 0.15 by both sides to get a spring constant of 10,000 newtons per meter. A spring is stretched 0.75 meters using a force of 30 newtons. What is the spring constant? F equals Kx. 30 newtons equals K and then 0.75. Divide 0.75 by both sides. Oops. Cancels over here, so 30 divided by 0.75 is 40. This has a spring constant of 40 newtons per meter. Number 7, how far? So you're looking for x. F equals Kx. Let's see. This time you have a mass, so you need to do mass times gravity equals Kx. 0.4 times 9.8 equals 300 times x. So 0.4 times 9.8 is 3.92. Divide 300 by both sides. And the distance is 0.013, and that's meters. Number 8, a here's a mass again. What is the spring constant? So F equals kx, but it's the force of weight, so we can replace that with mg equals kx. 7.5, 9.8 equals k, 1.1 meters. Divide 1.1 by both sides. And you get 66.8 newtons per meter. Spring constant, so, oops. Okay, so this time we have K and X. So we can multiply those two things together to get force, but we're still solving for, this time we're solving for mass. So I could replace that with mass times gravity equals 875, 4.5, and then I can also replace the G with gravity. Do it like that. So I'm going to multiply 875 times 4.5 to get 3,937.5, and then I'm going to divide that by 9.8 to get the mass. So mass would equal 401.78, so I'm going to round that to 8. And mass is kilograms. Spring with a spring constant of 25, a stretch 65 centimeters was the force. Be careful with centimeters. You need to change that to meters because you're using meters here. So you just move it over 2, so that's 0.65 meters. So F equals kx. What is the force? Spring constant's 25, x is 0.65. 16.25 newtons. Number 11, a 25 Newton force stretches a spring. Okay, so there you have centimeters again, so you have to go 2 over, so that's 2.8 meters. So F equals kx. 25 newtons equals k times 2.8. Divide 2.8 by both sides. 8, you get a spring constant of 8.9 newtons per meter. And you can check all my answers here below. Actually, I just realized we had the answers. Whoops. Okay, and then the last one, number 12, says a 75 Newton force stretches a spring. There you have centimeters again, so 2 over 1.75 meters. So F equals kx, 75 equals k, 1.75, divide 1.75 by both sides. 75 divided by 1.75 is 42.8 newtons per meter. All right, and you can check your answers down here as well.